I will just get started with a very brief introduction sort of to what engineering world health is and who I am. And I figure since, we'll have this sort of changing group of people coming in and out, definitely feel free to ask questions at any time. Don't feel required to wait until the end. I'm happy to answer questions along the way. And if it's something that I'm planning on addressing later in the PowerPoint, no problem. I'll just mention that. And yeah, so definitely feel free to jump in, make comments. I think Zoom has like a raise hand question feature. If you want to use that, no problem. But also if you just want to jump in and say, hey, Megan, what are you talking about? That is cool as well. So a little bit of background about Engineering World Health. We're a nonprofit organization. We're based out of the United States. Today, I'm coming to you from our office in Durham, North Carolina. I was telling some of the folks already online here that's on the eastern part of the United States. And today we're experiencing some fun storms and things. So if the power goes out, we'll power. I've got a laptop, it's fine. But basically, Engineering World Health is a nonprofit, and we're focused on empowering the biomedical engineering community in low resource areas. So a lot of the times, there's a few different ways that we do that. But a lot of the times that means physically being in low resource countries and in developing areas around the world and working with biomedical technicians in those areas. Sometimes that means doing a lot of like STEM K through 12 outreach, where we're working a little bit more locally or with schools abroad, and really just promoting and educating the biomedical engineering community so that they can have that trickle-down effect on healthcare in low resource areas, and that we can all jointly sort of work together to improve healthcare in low resource areas. So a little bit about me personally. As I said, my name is Megan Lavery. I studied biomedical engineering and international studies kind of jointly at Virginia Commonwealth University. Again, that's in the United States. And while I was working as a student, I studied in St. Vincent and the Grenadines, which is a country in the Eastern Caribbean, sort of off the coast of Venezuela, and is a low-income country as well. I didn't add those lines to the screen right there, so I'm not sure. Somebody's playing with markup, but that's okay. Yeah, and as a student, I actually went on a trip with Engineering World Health to Rwanda, and I worked in hospitals in Rwanda to repair medical equipment as well. So as a student, I had these experiences in these low-income countries, and they were pretty influential on the path that I decided to take. And I ended up, after I graduated from university, becoming a biomedical technician for a couple years in the United States. I traveled between hospitals in the United States and repaired medical equipment, a lot of times working on sterilizers and autoclaves and surgical equipment. And after gaining a little bit of technical experience there, I'm now the Institute Manager of Engineering World Health. So what that means is a lot of times I will travel with students, with university students, to low resource areas abroad, and we'll work together with hospital staff and everything to repair medical equipment in low income hospitals. So these are sort of all the countries that EWH works in. I'm going to see if I can get rid of the annotations on the screen. I was hoping they would disappear when I jump to the next slide, but perfect. Thank you, whoever managed that one. So these are all the countries that EWH is currently working in. Of these countries, I've worked in Rwanda, I've worked in Uganda, Cambodia, and the Dominican Republic, as well as done a little bit of outreach in Kenya and a couple other places. So a lot of these programs are where we hold what we call our Summer Institute programs. And these are generally 9-week programs where we'll bring university students to volunteer and study with us on the repair of medical equipment. And then we'll all jointly, or we'll do that in country for 4 weeks or so. And then students will spend 5 weeks placed as a volunteer in a hospital to repair medical equipment. And we'll get more into what that as a process actually looks like later on. But some of the other programs that we have run in the past, we used to do a lot of biomedical technician training. So we had BMET training programs, and BMET just stands for biomedical technician. And these are the individuals who are repairing medical equipment in hospitals. So we had BMET training programs in Ghana and in Nigeria, as well as in Rwanda. And those programs have actually been completed. And now we're focusing our efforts a little more on our institutes and things like that. So you can sort of see we're generally all over the world. You know, we're not focused in one area so much. Right now, we do have a lot of involvement in East Africa, but we've touched a whole bunch of different places, which is a really cool part of our organization and our involvement globally.
Megan, can I interrupt you? I don't think your slides are changing.
Oh.
Yeah, well, we're still on the first slide. Sorry.
Good to know.
Yeah.
All right, let's. So you're just looking at Huruma Hospital then?
Yes.
That's disappointing. Okay, hold on. Let's see. All right. If I change the slides now, does it shift? Fantastic.
Yeah, now you're good.
You did my wonderful work.
Sorry.
That's fine. I'm glad we figured that out now. Okay. Well, there's me. This would have been a lot better of a slide to see as I was talking about myself. But to touch very briefly back on it, I was a student. I had all these cool worldly experiences that inspired me to become the institute manager of engineering world health. And sort of here's me working in hospitals in the US and abroad as well. This is fixing an autoclave overseas and working with some students. So now you got the whole picture. And here is what I was just referring to in terms of sort of our global impact. So you can see all these different areas that we've worked in East Africa, as well as throughout different parts of Asia and different parts of Central America and the Caribbean. So fantastic. So continuing on that, sort of what we've been doing over the last, we've actually are coming up on 20 years as an organization, and that has some various stages as far as what that means in terms of our involvement. But as far as like our institutes are involved, you know, we've had over 1,100 participants over the last, since 2004. We've repaired over 12,000 pieces of medical equipment, which is a huge feat. We're actually, I think we've had 9 countries supported, and that comes out to be over $25 million worth of medical equipment done by the repairs and things that we make in countries. So those are sort of our accomplishments there that we're pretty proud of. But why are we even needed in these countries is sort of what I want to get into over the course of this conversation that we're having. So basically, the World Health Organization found that 40 to 70% of hospital equipment it is out of service in the developing world or in low resource countries. So even when hospitals potentially have the resources to hire biomedical technicians, it might be difficult to find certified biomedical technicians. And this is due to a whole bunch of reasons, but a lot of it has to do with lack of access to training in developing areas. So you can see on the picture here, here's one of our board members and one of our previous students walking past what we call an equipment graveyard. And so this actually took place in Rwanda, and this is in a hospital. So all of these machines are infant incubators. And this is a situation where a hospital has so many unworking infant incubators that they're actually having to store them outside in this storage area, AKA this equipment graveyard, because of various reasons that contribute to them not working. And a lot of hospitals will actually have to either pay to dispose of not working equipment, or they'll end up just keeping it sort of indefinitely because they don't know what else to do with it. So there's all sorts of issues that leads to the existence of these equipment graveyards that you really don't see existing in high resource areas. So I want to talk about why we're seeing so much equipment out of use. First of all, what categorizes a low resource hospital? So in high income countries, in the United States or the UK, when a piece of equipment breaks down, generally either a new component is ordered from the manufacturer or the entire machine is replaced, and it's just sort of done like this. You get somebody like Steve over here in his white work van who comes to the hospital and will replace a piece of equipment, and that's sort of the end of it. And you get Todd down here who's really happy because he sells you a new piece of equipment when yours is broken, and that's sort of the process of it. But none of those options is really available in low resource settings. You don't get a guy in khakis coming in his work van to East Africa to come fix your machine. So the vast majority of medical equipment that is manufactured in these high income countries, so in the United States, in Germany, and in Japan, just you can't get the parts, you can't get the resources once those pieces of equipment end up in other countries, particularly in low resource areas. So because like most of that equipment that gets there is actually getting there via donation. So while there definitely are situations where hospitals are buying their own equipment and getting maintenance plans or might have ways to sort of get those fixed, a lot of equipment ends up coming via the donation chain. And when that happens without access to regular customer service supplies or user trainings provided by a manufacturer, or sometimes even instruction manuals that don't come with a piece of equipment, you're finding yourself in this setting that you don't have nearly any of the resources as normally come with that piece of equipment. So talking about the donated equipment section a little bit more, what we have found and what EWH and its founders found is actually that 39% of all donated medical equipment arrives to that hospital in a low resource setting completely unusable. So even before it is taken out of the box after shipment, it's completely unusable. And then within 5 years of taking it out of the box and potentially setting it up for use, another 58.5% is dysfunctional. So after a 5-year period of donating a piece of medical equipment, only 2.5% of that equipment is found functional. And so this is an example of another hospital in Tanzania. This one is sort of stacked up with medical equipment, and this is another area that we would call an equipment graveyard. So you see all sorts of hospital beds back here. You see all sorts of, we've got like the motor to a suction machine. We've got tea kettles. We've got drawers. On the left side here, we've got containers that are used to sterilize surgical tools and things like that. Those would go into autoclaves. And so these are just piles and piles of not working equipment. And this is actually taking up an entire room of a hospital that they can't then use for patient care because it's just full of broken medical equipment. So why so much equipment out of service? We'll talk a little bit about the cost of medical equipment and how it means that places need to get donations instead of buying their own. We'll talk about trained BMETs, that donation process a little bit more that we touched on. Access to spare parts is a huge deal, as well as tools and whether or not an individual has the tools to fix the medical equipment. User training and manuals is a big deal. If you can't get the information about a piece of a machine, it's really hard to manage it, as well as sort of this really sort of global issue, which is reliable electricity and clean water. If you can't run your machines with clean water and you don't have access to electricity that consistently powers your hospital, you can't use devices which require electricity and clean water. That one's pretty straightforward. So touching a little bit more on this donation spare parts tools process, why are we seeing this huge amount of donated equipment being dysfunctional? Well, on the face, that 39% that's arriving unusable, a lot of this equipment is being shipped with defects. So in the United States, for example, we can get tax deductions by donating our used medical equipment, or hospitals can get tax deductions by donating used medical equipment. So when things break or when things no longer suit our hospitals here, a lot of times they get donated to organizations that then send them abroad. So organizations or church groups or whoever. But some of these are just flat out broken to start with. And that's a huge problem because it's a way for us to sort of get rid of our junk, and instead it's ending up in hospitals that are hugely burdened by it. So that's definitely an existent problem. Additionally, even like really well-meaning people trying to donate good working medical equipment might be missing components. So if you have a piece of medical equipment that requires on a very specific type of accessory, so if you have an electrosurgical machine, which is used to like cut and cauterize an individual during surgery, but it requires a very specific type of pen that you physically use for that cutting and cauterization. If you donate the device, but not the pens that go with it, this thing is now unusable because, as we talked about before, it's really hard for people in low resource areas to get all of these different parts and pieces that might come with a specific device or that you could order and have shipped to you here. That's just not really a possibility. So if you're missing components, it makes it pretty much impossible for a lot of people to use it. Additionally, sometimes equipment is used and it's set up to be using, you know, a power supply in the United States. So let's say you have a device that's designed to use a 120 volt power supply that comes from the wall here, but you bring it to another area of the world and they have a 240 volt power output coming from their walls. So as soon as somebody plugs it in, capacitors in the machine blow up and then it's pretty much out of use. So unless you include a transformer and voltage regulators and things like that along with it, you end up seeing a lot of problems. And a lot of the times it's donations that are very, very well-meaning. It's coming from individuals who say, hey, I have this great piece of equipment, we're not using it here, let's give it to somebody who could use it, who just don't fully understand the scope of the environment that they're donating a piece of equipment to. And that's sort of why we're seeing so much equipment arrive completely unusable on arrival. Excuse me. In addition, what we're seeing is that there's not any consumable parts. So by consumables, we mean things that have to be replaced after one use, maybe for sterilization reasons or whatever. Parts that are designed to be used once and thrown away. If a device requires this constant stream of materials in order to use it, that's just not something that's reasonable or feasible in low income areas. So again, using the electrosurgery device, sometimes these pens are only meant to be used once and thrown away because they're entering inside the human body and therefore are a high risk for infection. We'll design them in the United States or in the UK to be, you know, used once and thrown away. But what you'll see is hospitals then only have a couple of these pens and trying to use them over and over and over again. And they're just not designed for that kind of wear and tear, let alone the infection risk. So continuing with that a little bit more, we get into the infrastructure and installation of them. You know, if a hospital doesn't have consistent enough power to regulate a piece of equipment, that's going to cause huge issues. So if a hospital on a regular basis sees power surges throughout their building, which is very common, a lot of times you'll see equipment with blown capacitors and things like that, and that knocks things out pretty quickly and ties into our 5-year timeline of why things go, of why things break. Finally, a little bit about manuals and user training. If a piece of equipment is donated with all good intentions, but doesn't include the manual that it came with, it's really hard for people to install it, right? Or to understand how to use it because you just don't have this critical piece of information. Furthermore, if it's donated in a language that people don't understand, having the manual itself doesn't do a lot of good. So equipment a lot of times will never even get installed because people don't have the information of how to set it up. It comes in a box in a bunch of different pieces, and your instruction manual doesn't make any sense. It's a huge factor contributing to why equipment isn't used. In addition to the tech support that we talked about and access to spare parts for it. So I want to get into the access to spare parts a little bit more. So I'm just going to go ahead and read you my next slide. So while more generic spare parts might be easy to find, specialized spare parts such as equipment-specific light bulbs and printed circuit boards and things like that can be really challenging, if not impossible, to find or replace, as you might imagine. So even if the part itself, when you're located in a high resource area, is really inexpensive, if it can't be found in country, it can cost hundreds of dollars and tons of time, talking up to months, to ship that small piece, that small inexpensive piece to a hospital to get their machine up and running again. So a lot of parts end up having to be ordered from specific manufacturers or from specific dealers. If a board in a patient monitor, or we can take an infant warmer because that's our picture here. If you have a control board on that, that requires certain settings and things from its manufacturer, really the only way that you can fix that and get that replaced is by going directly to the manufacturer. And if they aren't willing to ship it to you for free, which is a pretty rare occurrence, your piece of equipment is just out of use, and there's not a whole lot that can be done. Sometimes we'll see that shipping, like the cost of shipping a single board after, after going through cross-country freeze and immigration and customs and everything like that, ends up costing the amount of an entire new device itself. So there's all sorts of different factors that make it really, really difficult to maintain these devices. So touching back on sort of that cost, and again, why we can't train people in country to do a lot of these repairs and things. Well, technicians don't always have the time or the budget to go looking for spare parts. So it's not uncommon to see that technicians are not only responsible for repairing medical equipment throughout an entire hospital, but they're also responsible for running an ambulance, or for keeping all the lights on in the hospital, or keeping air conditioning in the labs and things that need air conditioning. And a lot of the times it's just a matter of not having enough people and not having enough man hours to do all the jobs that it requires to keep a hospital up and running, or the budget really. So what you're seeing is that when hospital technicians don't have access to the spare parts because they don't have the time or the budget to go looking for them, a lot of the equipment falls out of service. And then resultingly, doctors are not able to properly diagnose and treat patients. If you have a biomedical technician who just doesn't have the time to go out and look for spare capacitors or voltage regulators or things like that to fix this piece of equipment that got blown up because you plugged it into the wall, a lot of the times then a doctor ultimately won't be able to use that patient monitor to diagnose patients. And it's just sort of this chain of events that you see over and over and over again. So in order to be truly effective, a technician not only has to be skilled with technical maintenance skills and the ability to repair medical equipment, but this individual also has to be incredibly creative and patient. They have to find all sorts of different ways to repair devices in a manner that's hugely different from what that would look like in high-income countries. When you don't have access to spare parts, you have to jerry-rig things together, for lack of better terms, or you have to get your MacGyvering skills together. And that's a huge part of what it means to be a biomedical technician in a low resource area that is just not part of being in a high resource area. Similarly, this individual needs to be familiar with the political and bureaucratic landscape of working within a hospital and healthcare system. You need to be able to advocate to a hospital director why funding for certain parts is so important, because if a hospital director doesn't understand why these issues are happening with the devices, you're not going to get funding. So that falls onto a technician to, in addition to having technical skills, have that ability to, have those interpersonal skills and advocate for the entire field within his hospital. And similarly, exactly, diplomatic skills and working between wards and things like that. So if a piece of equipment keeps coming back from a pediatric ward, and you keep saying to them, I can't fix it, I can't fix it, I can't fix it, you end up having bad relations within the rest of the hospital. So you've got to be able to help others understand, why these different things are happening, and really have those diplomatic skills to work on higher levels and around other hospital staff. So ultimately, success in maintaining medical equipment is not just based on physical tools and skills and things like that, but on a technician's ability to communicate and collaborate and share trust within the rest of the hospital. So it's a huge task, and I would argue a much, much bigger job than any technician has in a high resource area. So one of the other bigger problems that you'll see as a result of this is you get these individuals who are highly qualified, and you see what's called brain drain coming from low income areas and going into high resource areas. And brain drain is sort of this concept of taking the most educated of an area. So taking, if we talk about Uganda, for example, we take the most educated biomedical engineers and technicians in Uganda, and they work in Uganda for a while, and then they say, well, I could have this really difficult, challenging job here and not necessarily make a lot of money, or I could go work in the UK for a while with my level of education and training and experience, and I can make all this money and be living somewhere that I have a lot more resources. My job is easier. I can potentially send resources back home, and a lot of people experience this, and it's an ongoing problem sort of across all disciplines when it comes to low resource areas, is that you have your most educated and experienced individuals that will leave low resource environments and travel to high resource environments because it's a better setup for them on an individual level. And biomedical engineering and working in hospitals is definitely no exception to this. You see this with doctors, you see this with nurses, you see this with engineers and technicians and sort of everyone across every discipline that you can think of. But it's definitely apparent in a hospital setting as well. So in addition to that, I touched on user training and manuals a little bit, but that's definitely a huge contributing factor. If manuals aren't available to those individuals, there's not much one can do about it. And the same goes for user training. So if hospital staff don't know how to use a piece of medical equipment, and there's not a clear instruction guide that says, like, hey, this is how you turn the machine on, this is how you access these features, this is how you connect it to the patient, and so on and so forth, it's really hard for staff in the hospital beyond the biomedical technician to understand how to use that device as well. So a lot of times in areas where maybe that user training comes directly from a manufacturer, that is a big problem because access to that becomes very, very limited. And finally, we again touch on the reliability of electricity and clean water. That's something that impacts every field you could imagine in low resource countries. If a hospital doesn't have access to clean water, you can't adequately sterilize your equipment. You can't safely hold surgeries and things like that because you risk because you have huge risks of infection and everything like that. Again, reliable electricity. If you can't run your devices which run on electricity, that sort of knocks out a huge element of your practice. So what effects does all of this have on healthcare? We've talked about a few of them, but a lot of times it means that patients aren't able to access care in their areas. So, maybe you have 4 clinics around a village, but none of them have reliable equipment. None of them are able to, have the reliable electricity and things like that, and the resources to run their practice. So patients a lot of times with simple illnesses will have to either wait potentially weeks or months, or they'll have to travel extremely far to receive treatment. So, I've seen tons and tons of individuals who I've talked to and have said, yeah, I've traveled, for 7 hours to have my leg looked at. Say an individual gets in an automobile accident or something like that, and they have to travel 7 hours to then have x-rays and things like that done. And that's just a very common occurrence, unfortunately. Sorry, there's a train going by my building, so I'm not sure if you hear all of that in the background. I'm sure you do. It should be over in a minute. But in addition to people having to travel hours and hours and hours, you're having procedures that just can't be performed in certain areas. So if a surgery can't be done, and somebody can't travel to go have it done, you're just sort of out of luck. Or you're going to see, like, the few hospitals who are able to do that surgery are incredibly overloaded with patients. So if everyone from around the country is having to go to 3 different hospitals to seek surgery, basically just a standard practice surgery, then like those surgeons in that hospital is going to be completely overwhelmed with that. And we definitely see that a lot as well. So when procedures can't be performed, obviously you're going to have a lot of negative outcomes on the general public health of an area. Your safety is compromised. The efficiency of being able to get people in and out is hugely diminished, and then resultingly revenue is diminished. So in areas that require on either government funding or on individual patient funding to sort of keep themselves supported, if you're not able to provide services, you're not getting that revenue, and it's just sort of this downward cycle of not being able to provide care to patients. I'm going to jump forward a little bit into sort of how engineering world health tackles some of these problems. And I'm going to focus pretty largely in the beginning on sort of the summer institute programs, because those are what I run. Those programs that I was talking about that last 9 weeks. And what happens is we'll bring large groups of students with us, usually undergraduate engineering students, sometimes graduate students, sometimes a couple young professionals. And we'll train students for 4 weeks long on how to repair medical equipment. And all of this training happens in country. So you'll train with us on what's important to know, what the key issues and things like that are. And then you'll be placed for 5 weeks in a low resource hospital. And what you end up doing there is working, number one, to fix medical equipment and service existing equipment and keep it maintained and things like that, but then also to sort of educate staff on the different ways to repair pieces of equipment, or the different ways to keep equipment going and things like that. And hopefully from that, you're able to take a lot of knowledge with you about sort of how to participate responsibly in this donation process that we spent so much time already talking about. And what it means to design a piece of medical equipment that's appropriate, not just for high income areas, but for low resource areas as well. So that's sort of our goal with the Summer Institute programs. And I will talk a little bit more about those. So like I said, each program is a little over 2 months long. It's 9 weeks long. And you have 1 month of technical and language training and 1 month of working in a developing country hospital. So that technical and language training is actually is very intensive. We'll have up to 4 hours a day, nearly every day of students learning the local language. And that's super, super critical to what we do, and making sure that, we're not just some outside organization coming in for a couple weeks and then walking away. We need to be as well integrated into the community and have the greatest level of understanding about the local community as we possibly can. So we do language and cultural training, as well as intensive technical training for all of our volunteers, who are then placed into a hospital to work with hospital staff and work within a specific community. So that classroom portion, sort of what does that look like? Well, we focus a lot on the technical and engineering skills needed to make repairs. So we'll go through the common problems of all sorts of different pieces of medical equipment. We'll go through the design of pieces of medical equipment and what they're intended to do and things like that, as well as how to make repairs to those common problems, as well as some other things that you might see, and work on general troubleshooting skills and everything like that. In addition, we study the function and the design of medical equipment, as well as lab equipment, and sort of talk about what is most commonly found in certain areas, and how that differentiates from what you might see in a hospital in a high income area. And then, as I mentioned before, also talking about that local language experience and the culture of what you're in. That's a huge part of what we do. And then still during that sort of first month period, our students also get a lot of field work. So we'll do group hospital visits and things like that, and we'll allow all of our students to travel with their instructors and coordinators and things like that to go work in hospitals, and sort of ease you into that process of becoming an independent biomedical technician in a community. And we'll also go on cultural outings to help with that cultural understanding. We'll do all sorts of labs, sometimes with students local to the environment. So if the country, if we have a partnership in the country that allows us to work with engineering students. We really highlight that as well. And so you might spend a lot of time working with other engineering students from that community, as well as, you know, sometimes doing K through 12 or like elementary and other STEM outreach within communities. We'll sometimes do outings that involve that sort of work, as well as working with biomedical technicians within the country that you're volunteering in. And then finally, it brings us to hospital work, right? You know, sort of the primary reason that you're there, and a whole 5-week section of your time there. And that's spent, you know, improving your technical skills and applying them to a hospital setting. So students, in addition to repairing medical equipment, will a lot of the times train staff on how to use that equipment. They'll develop user guides, either without like language requirements, or they'll develop them in the local language so that people understand how to use a device. A lot of our students will spend time translating manuals and things so that they're much easier to understand. And then finally, you get a lot of like personal gain out of that as well. And that's okay. That's a big part of the experience. And you know, students really benefit from being able to have relationships with staff and technicians, and gain a little bit of understanding about each other's lives and the challenges that face you inside a hospital setting and outside, and get to know the local community a little bit more, which is a really fantastic part of our program. Additionally, once you're in this sort of community setting, our students tend to work and live independently. So our students will have a group of either 2 or 3, and so you'll be out in a community in a slightly more rural area, and will work sort of independently with your hospital and within your community, which is a really big deal for a lot of students, and something that I think most of our participants gain quite a bit from. So without talking too much more about the summer institutes, what are some of the other ways? Oh, and then finally, at the end of our summer institutes, we have all of our participants develop what we call a secondary project. And so in addition to all of the work that they've done over the last 5 weeks, they analyze a problem that's going on in the hospital, and they develop a solution to it. So what a lot of these students end up doing is taking either a technical or a non-technical approach towards contributing something to the hospital. So students will spend a lot of time either like sometimes painting hospital wards, you know, painting a pediatric ward, or you know, putting up lights in a hospital and things like that, because that's something that's really mattered to staff, and that was an easy way for them to contribute and say sort of thank you for their time and for letting them you know, work at the hospital there. And then other people take a much more technical approach to it. We've had students design water shutoff systems for water supplies for the hospitals. We've had students design patient call or nurse call systems because the hospital didn't have any nurse call buttons by the beds and things. So they developed a whole system for that. And that's, you know, there's tons and tons of cool secondary projects that our students come up with that really highlight the different needs that hospitals have in low resource areas that we might not even consider in high resource areas. So we've had tons of groups focus on different safety issues around the hospital. Sometimes that being like the transportation of oxygen cylinders and keeping up with like health and safety standards that we have in high resource areas that are hard to meet in low resource areas, and all sorts of things like that. So that's another big part of what our students do. So to pitch really quickly to you guys, and I don't want to go too heavy on this, we are going to have 3 programs this coming summer of 2021, or at least we're planning to, COVID permitting. So we'll be running programs in Rwanda and Guatemala and in Tanzania. Guatemala obviously being in Central America, and Rwanda and Tanzania both being in East Africa. So if you are interested in coming and participating in a summer institute or something like that, you can definitely check out more information on our website about that, or feel free to reach out to me about it. A little bit of an overview about the programs. You know, you saw those timelines here. We've got Rwanda, which starts the earliest, and then Guatemala, and then Tanzania. So you'd have to look at your school schedule and things. But a little bit of an overview here. Our first month locations are generally in more populated, developed areas. So in Rwanda, we have our first month that's held in the capital. In Guatemala and Tanzania, we're held in other large cities around the country. You can see we work in several different languages here. And a lot of the times and for all of these programs, our students, at least for the first month of participation, stay in a homestay, which is a really big part of our program. So students will stay and live with a local family, which really, really helps in incorporating into the local culture. So Guatemala is a homestay all the way through, as opposed to Tanzania and Rwanda, which you might end up living independently during the second month. And you can find a lot of those differences on our website and more details about all these programs there as well. So some slight differences in these programs. Whether or not hospitals in these countries have BMETs or biomedical technicians, a lot of the times varies. So you'll see in Guatemala that some hospitals have BMETs and others don't. So you might be placed in a hospital with a BMET to work with, and others, like, you'd be working independently or with general maintenance staff. In Rwanda, a lot of the hospitals do have biomedical technicians, so you can work a lot more closely, sometimes on more technical repairs and things like that, as opposed to in Tanzania, where biomedical technicians are just not a very common thing for hospitals to have at all. So a lot of times you'll be working on sort of less technical, but potentially more critical repairs, because you'll see greater amounts of equipment not being used because there aren't trained biomedical staff in how to fix it. So in addition, during that time, you have 24-hour support from our staff. So we'll have somebody, a coordinator, or likely two coordinators in country with you. We have an instructor throughout that entire first month. You've got 24-hour access to our resources and to getting in contact with us, as well as, communication in country is just sort of a constant thing within your group and with your coordinators and things like that. And you have all of our technical assistance and guidance throughout that time as well. So after the program, a lot of the times what people end up going on to is furthering their technical skills and furthering their degrees and things like that. But we have people come back all the time as on-the-ground coordinators. So we'll have people come back to our programs either as an alumni wanting to participate in a program, or we'll have people come back through wanting to work for us as a coordinator and run a follow-up program. Last year we were pretty proud of having 100% of our students recommend the program, and so that was exciting. And if you're interested in sort of hearing those individual stories and seeing what things were like for them, you can definitely check out the blogs and everything that we have on our website, and more of the testimonials and things there. So if you are interested in going for a summer institute, we've got 3 deadlines this year. We admit on sort of a rolling basis. So we have deadlines November 1st, December 4th, and January 22nd. You can apply to any of these deadlines and get a response from us. But I will say generally, the earlier you apply, the more spots open there are. So that's always a benefit. And you can definitely check out our website for more information. I highly, highly recommend going and downloading our application packet, as it has the most information of any of our documents on sort of what this looks like and what it means to take part in one of these programs. But these are sort of what is required for the application. And if you have any questions about this, definitely feel free to reach out and touch base with us about that. In addition, we do offer, this is a program that charges tuition, but we do offer financial aid and help guide students in where they can find external scholarships and everything like that, so that the earlier that you apply, the more financial aid we do have available. Important part this year is that we know that COVID is a pretty big deal and has the potential of causing a lot of problems with this. So we won't be taking any deposits or any funding or anything for these programs until March 1st. And it's at that time that we'll be able to make a more educated call on, if any changes need to be made to the programs, or, if unfortunately programs need to be canceled or anything like that. So you have pretty much between now and March 1st to say, hey, I can't do this, or I can't afford this, or anything like that. And you won't lose any money as a result. So with that said, if the Summer Institute isn't necessarily something that you want to get into or take part in this coming year, which is totally fine and reasonable, we're also holding what we call our virtual Winter Institute. So for the first time this year, we held sort of these online programs for engineering students between the United States and Lebanon. And what we're doing is holding a design challenge and a design course on engineering challenges for global health, and what that process looks like, and having a course focused on that, and pairing students from all over the world to work on teams together, and work on a design challenge. So this is going to take place in January of 2021. We're taking applications through December 1st. And we will be partnering with Lavery University, which is in Uganda, to pair students from high income areas with students in low resource areas. And we'll be working with biomedical engineering and other engineering students from that university to make sure that we have really cool international teams. So if you're interested in participating in that sort of design challenge, it could be something that's really neat. And I definitely encourage you to check out. Similarly, there's different ways to get involved locally if that's more what you're looking into. We've got chapters at universities all over the world. I know this is part of the EWB chapter, and I won't try and oversell too much to that, but if you are interested in global health specifically, and sort of biomedical engineering, you can start a chapter at your university, and you can take part in our annual design competition for global health challenges, and earn scholarships and things that way, which is always a really cool thing to do, and do more local outreach and coordinate with other chapters around the world. So that is the end of my PowerPoint, and I've gone ahead and put some information up here about how you can get in touch. I can't see which email I have on there. Yeah, there we go. Megan@ewh.org is my information, so definitely feel free to reach out. Pretty much at any time is fine, but I want to go ahead and open the room up to questions if any of you have any.
Hi, I'm just going to nip in here quick if that's okay. Thank you, Megan, for taking your time to talk to us. The summer program definitely sounds like an amazing opportunity. So I just want to make a couple of EWB Society announcements first. So EWB Family Scheme sign-up forms and fleet orders will be closing tomorrow. So please do make sure and sign up in order. The links to those will be in the chat now. And also, if you would like to become a STEM ambassador, make sure to join the Outreach Facebook group, which will be also in the links in the chat. And look out for any upcoming posts on there. And one last thing, our next Spotlight lecture is on the 12th of November at 6, and it will be given by Nav from the Washing Machine Project. So yeah, time for the Q&A, and remember, the person who asks the most insightful question will win a free pizza.
It's a good deal.
Hello, I'll go first then. So to what extent are the problems with medical equipment due to the initial design and them being focused on being used in high income areas?
Yeah, that's an excellent question. I don't know that I can give a numerical value to that question, but I would definitely say to a high extent. We don't see a lot of widely used medical devices that were designed by someone in a low resource area. And sort of resultingly, a lot of the problems that equipment has end up being from problems that don't exist in high resource areas. So if I take like a nebulizer, something that's commonly used to treat like pneumonia and other respiratory device or illnesses, And I'm used to this device running in a, indoor air conditioned area, and it's only used for a few hours a day, and it's really no problem. And that in that sort of setting, it might last for years and years and years. But if I take that same device to St. Vincent and the Grenadines, which is a Caribbean island and has high humidity and the air is salty and there's dust because the hospitals are open air environments, they're not sealed in environments, and there's definitely no air conditioning and things like that, that nebulizer, which previously would have lasted years and years, it starts breaking down after potentially weeks to months. And especially if it's used at a more constant rate than it is here. A lot of times we'll have devices that will only get a couple hours of use per day, if that, here, but are being run 24/7 when there is only one or two of that device. So I would say to a very high extent, problems with devices are a result of them not being designed for a low resource setting.
So Hasina in the chat has asked, regarding donations, what efforts are put in place to reduce equipment ending up in the graveyard? What measures are put in place to reuse, repurpose what can be recycled?
Yeah, if you will bear with me for just 1 second, I'm going to bring the blinds down a bit. So a lot of those efforts are being used on the part of or by hospital staff. So like I said, the people who end up donating medical equipment and things like that are really well-meaning people. Like, nobody's just like, yeah, let me just dump all this stuff and sending it to low resource areas. I mean, I guess people could be doing that for the tax deduction, but it's generally very well-meaning people doing that. And it's just that people don't understand that it is causing a problem at all. And what you'll see is in a lot of low income cultures, there's cultural differences where you're told to accept something, and you're told to accept donations and gifts that are given and not to complain about them. So a lot of people just don't know that their equipment donations are actually causing more problems than doing good. So sort of what ends up happening is it falls back on hospital staff to then deal with the problems. And there's actually not a ton being done in terms of stopping these donations happening altogether. Obviously, there's education efforts like what we're doing, trying to figure out where donations come from and talk to groups like you all and everyone about this process. But I would say on the part of a lot of donors, a lot of it is just a matter of lack of understanding. So it's almost hard to tackle that problem beyond explaining what's happening.
I have a question. So, I mean, this kind of relates back to the last question, but to what extent would you say that, like, training for the actual, like, the people donating is actually more important than the training for the, like, the hospital staff that are actually going to be using it?
I don't think that I would say training the donors is more important, because at the end of the day, even if they say I shouldn't donate this piece of equipment because it has XYZ things wrong with it, hospital staff still need to have something and be able to work with what they have. So I guess, you can't just train people to not make donations and then leave hospitals without anything. But I think hospital staff need to be trained, not on how to fix people's broken donations, but how to perform repairs on proper working donations. So I don't think it's necessarily one over the other. I think both are pretty critical elements, because you need to continue training staff. But we also don't want to overburden them with the additional task of then having to figure out how to repair, like, equipment that's not right for the environment, on top of having to understand how to make, appropriate repairs.
I can add to that if you want, Megan.
Go ahead.
I will say hi, I also work for Engineering World Health, but I'm not an engineer. The World Health Organization also has a checklist of best practices for medical equipment donation. And there are some of the donor organizations, like Project Cure, they have measures in place, like basically troubleshooting the equipment before they send it abroad, so that they know at least that when they sent it, it was working. So that is one way that you can help improve this.
Definitely.
Right. Amy Thomas asked, outside of engineering work, does EWH do work towards solving the social issues that contribute to healthcare problems in these countries?
So that is a huge task, and I think one that unfortunately is well beyond the scope of what any international nonprofit organization could handle. You know, when it comes to social issues that contribute to healthcare problems, I don't think anyone outside of the country that you're focusing on has the experience and the level of understanding necessary to tackle certain healthcare problems. So you have tons and tons of NGOs who work to promote education and things like that. When it comes to certain healthcare, when it comes to certain health issues and social issues and things like that, and that's being approached by thousands of NGOs and nonprofits globally. But I also don't think that we can rely on nonprofit and international humanitarian assistance to make all of the socioeconomic changes that need to happen within low-income countries in order to address some of those problems. So I would say in terms of what EWH does is try and educate our volunteers to the highest extent possible on those cultural and social issues at that contribute to what they will see in the hospital. But I think it's very important that we don't promote the idea that we as you know, young international volunteers have the ability to solve those problems. You know, we're not here to come in and volunteer and save Africa. It's not possible. It's not how we should approach those issues. But I think that we do need to take time ourselves and pay attention to them and learn about them, because that's how we're going to become better global citizens and better able to contribute internationally altogether.
I think that's probably the time up. So Gabriel, do you want to announce the winner of the free pizza?
Yeah, I think that last question, and particularly the last response, was really interesting, actually. I think I really enjoyed that. I've said "thok you" rather than "thank you" at the end. Bit interesting. Anyway, so I think the free pizza this time should go to Amy Thomas. So if she sends me her email address, just messages that to me, then we can sort that out at this end. Thank you again for talking. It's been really interesting, and maybe in the future we can sort of integrate some of the work that you're doing with some of the work that EWB does in the UK, because it sounds we have many common goals and common ideas. So we'd love to, you know, work more and work better in the future together. Thank you.
Yeah, thank you so much for having me.